Okay, so it does feel a little bit weird doing this again, but hey, we're here now. I think my last upload was about 3 or 4 weeks ago, I think. Me doing some sort of calculus question, but yeah. So if you haven't seen my community post, I've begun because of exams. I've been preparing for them these past few weeks. My first exam is in fact tomorrow. It is linear algebra at 9 a.m. 3 hours, but I can leave. I don't have to stay for the entire length though. From what I know, I can't leave in the first half an hour or the last half an hour. So yeah, any time in that 2 hour period in between is fine. And but I don't think I will unless I'm just confident in my answers. And linear algebra used to be a module that I really struggled with, but um, as of recent, but because I've been doing it so much these past few weeks, I've gotten really good at it. So just to kind of explain how it's broken up into. First term we looked at matrices, and then second term we looked at vector spaces. Or spring term I should say we looked at vector spaces. I am much better at matrices than I am with vector spaces, because to be honest, to summarize the matrices stuff that we looked at, it was eigenvectors and eigenvalues, row reductions, solving a system of linear equations, homogeneous and inhomogeneous. What else? We looked a little bit at diagonalization. Um, what else was a thing that pretty much sums up, and also a bit of decomposition and a couple proofs here and there. But yeah, for each of my exams, I'm allowed to bring in a two-sided piece of A4 paper with notes in it relating to that class. Let's cover that up. With some notes related to that class. And originally for this module, I had it written on my tablet. Tried printing it out, but the library was having issues. And the exam is tomorrow, so I couldn't really afford to waste any more time. So I just ended up writing it out on notes here. What do I have here? So yeah, this is the one proof that I've written down, just proving that AB all inverse is equal to B inverse A inverse. Got some properties of diagonal matrices here, some properties of determinants here. I try to sum these up as best as I can, just so I can save space. So yeah, row reduced echelon form of A augmented with I and then augmented with B is equal to I augmented with the inverse A augmented with the vector X originally. What else? Diagonalization here. Decomposition. Oh, also the vector space axioms. Um, I feel like because we can just my thought process was that because we have these cheat sheets, they're unlikely to just straight up ask us proofs, because then we can just write the proofs on our cheat sheet, and that's not like kind of testing our understanding of the material at all. So I didn't. So I've only got this proof here actually. Most I have on here. The axioms there that I've summarized. Some stuff about. The rest is vector space stuff. I'm pretty sure. So yeah, mappings. Mappings is something that we looked at towards the end of spring term that I do kind of struggle with. The basics isn't too bad, but if we get into like what is it even called? Uh, it's left my mind right now. I might remember if I turn the page. But yeah, change of basis matrix. I kind of understand it. Like I understand what we're doing. I believe we are writing one basis as a matrix in terms of like the coordinates of another. Wait, not the coordinates. Is it the coordinates? Okay, I'm gonna have to go back over that to be honest. I think it's the coordinates in terms of like another basis. But yeah, yeah, it must be the coordinates because it's a matrix of numbers. So yeah, yeah, we take like one basis and write each element of that basis in terms of another basis, and then get the coordinates of that and put it into a matrix. Got that on there. And what have I got on there? I will just rip this sheet out, of course, when I go to the exam tomorrow. Oh yeah, inner product requirements. Inner product's one of those things where like I understand it, but I feel like I can easily forget a lot of things on there. So yeah, I feel like these requirements could be quite important for me. like possibly proving something isn't in a product or showing why something isn't. Um, Orthogonal, I feel like I completely understand that. I just wrote it there just in case. Orthonormal, I do forget that quite a lot in terms of how to go from orthogonal to orthonormal. So yeah, what else we got here? Length, distance between two vectors. Your linear transformations. This stuff isn't too bad, honestly. I'm not too bad with it, I don't think. What else we got here? Oh, this was a theorem that I can't remember the name of. But honestly, thinking about it now, I don't understand it anyway. So just having this on there is a bit of a waste. Cause yeah, but yeah, it's here now already. It's too late. Gram-Schmidt. Okay. With Gram-Schmidt, I feel like I understand what it does. The Gram-Schmidt, excuse me, the Gram-Schmidt um changes a I believe a set of vectors to an orthogonal set. That's what that does. I'm pretty sure. It's only for bases. I'm not sure. It might only be for a basis, but I know that you can change um, a set of vectors from just themselves to an orthogonal set for a given inner product space. For a given inner product, I should say. It's just using the formula is a bit tedious, especially if like I remember for one question I have on a problem sheet, the inner product was the integral with bounds 0 and 1 from 0 to 1 of p of x times g of x. So yeah, like it was a polynomial vector space, and just doing that integration like literally 4 times to get the third um, orthogonal vector was so annoying. So I didn't really get much practice with it. Like I know how to use it, it's just in terms of speed, I didn't really get there. But I have 3 hours, so I think I should be fine. Um, yeah, this is just defining a projection and a perpendicular. I actually forgot what the proper name of that is, but oh well. So yeah, that basically summarizes this cheat sheet I got here. So yeah, it is currently the 1st of May, so I must see if I'll upload this today, excuse me, or tomorrow after my exam. My second exam is on this coming Friday, the 5th. That is calculus, also at 9 a.m., also 3 hours. For that, it's weird because I'm feeling confident, but also not at the same time. I know that's quite contradictory, but I think what it is the fact that like with the like most recent stuff we did, we looked at like what is it? If you have like a coupled pair of ODEs and then like graphing like on the face plane what they look like, whether you have a spiral, a node, what else was there? There was like a star and like a saddle point or something. I need to go back over it honestly, but at that point, that kind of stuff, I could just put it on my cheat sheet as well, but like I want to fully understand it, so just for speed. So that I need to go back over. But I do feel like at this current point in time, any like sort of first order ODE, I think I can solve. I'm pretty sure because we haven't looked at many different forms of ODEs. We've looked at near separable, Riccati, Bernoulli. What else have we looked at? Linear. Um, what else is that? I think that might be it, to be honest. Near separable, linear, Bernoulli, Riccati. Yeah, I do believe that's it for calculus. So yeah, I can solve all those just fine. For second order ODEs, if it's homogeneous, I believe that's the right word. Oh, if it's homogeneous when the right hand side equals 0, I think that when the right hand side equals 0, homogeneous. I hope I'm using the right word there. But yeah, if the right hand side equals 0, I should be fine. But I haven't practiced if like the right hand side is some other function of x just yet. I need to go over that. That's that. So that was the spring term stuff. In terms of autumn term stuff, that was more focused on harder integrals and stuff. Like for example, a double integral. I need to go back over that. Just like I do get the thought process behind it, but again, it's just speed. I don't want to really waste too much time on a simple question. So that's what my issue is with that. So yeah, for linear algebra, I give myself 2 out of 10. a good 8. I don't want to say 9 because that something could still go wrong, but I want to say 8. Calculus right now, honestly, a 6. But I think once I finish off the problem sheets that that I've been given, we should be back up to like an 8 or a 9 there. After that, I have my Foundations of Mathematics exam. That's kind of similar to real analysis, so as long if you get good at one, you get good at the other as well. That one I need to do a bit more work on. Honestly, I haven't worked on that in quite a while, so that's going to be I need to step up revision on that one. Statistics is after that. Um, I'm fine with probability. That's what the statistics part is going to be a nightmare because it's just like figuring out what distribution to use where. That I need to figure out. Again, I do get cheat sheets with all of these, so hopefully I might just have to write on there and pray. What else is that? Okay, and then my final exam is real analysis. Now, for those that saw my first ever video, I believe it is titled something like a look at a first year analysis assignment. If you watched that, you would know that I said that in my first that assignment is the second assignment that's come out for that class, and in the first one I didn't do that great. I got a 51. I didn't reveal that in the video, but yeah, I did get a 51 in that first assignment. And then with the second one, I got a 79.1, a huge improvement. I'm guessing if you see my community post, you'd already know this. But yeah, I'm much better at that now, so thankfully, so I'm feeling way more confident. My last exam is on the 31st. Real analysis on the 31st of May, so I've still got 30 days, plenty of time to get better at it. And between stats and real analysis, my fourth and fifth exams, I have 16 days, I believe. 16 days of like nothing else. So I'll have over 2 weeks to prepare for that. So I think by the time that exam rolls around, I'll be just fine. Okay. But yeah, that's basically what I've been doing these past few weeks. I'm just studying really in terms of my personal life. Well, let's see here. A new Berserk chapter dropped. I read that. It was great. Oh yeah, for my birthday, my friend got me this. I love this. It's supposed to be a book holder, but I have no books, so I just use it as decoration. Absolutely love this. But yeah, I think that basically sums up everything I wanted to say. I think the only thing I'm really gonna do now to prepare for my exam tomorrow is possibly answer some exam questions, and then I've heard that just like that teaching someone like some material makes it so that you fully understand it, and that's what I've been doing with some of my course mates that haven't studied as much as I have. So that's also like further cemented my understanding. I might just do something like tonight, just before I go to bed, where I just explain everything to myself of the entire course to make sure I get it, and let's see how that works. But as for now, that's about it. I'll probably make a short video tomorrow, just kind of detailing how the exam went, what kind of questions threw me off, what kind of question I think I did good on. But yeah, I will speak to you guys very soon, hopefully. See ya.